Hello and welcome all guys. I'm Rahul Kaushik and I welcome you all on Unacademy JEE English guys. And today we are going to start hybridization guys. Actually we were in the middle of the hybridization, and in the last class guys we have already covered what do you mean by hybridization, how many types of hybridization is there. And today I will I will teach you how to calculate hybridization of a particular molecule. Okay guys. First, let me confirm, guys. Am I live? Yes, just let me check it. Just a minute. Hello, hello. Please confirm me, guys. Am I audible? Just a minute. Let me check. Yes, I'm audible. So, guys, we can start. So, in previous class, guys, we did. In previous class, we did. I teach you guys the meaning of hybridization, and today I'm going to tell you guys how do we calculate hybridization on a molecule or a compound or anything, guys. So today's topic is going to be crucial because today you will be learning all these things, guys, how to calculate hybridization and what is the meaning. Basically, last time I just taught you the meaning of our hybridization. Now, on any molecule, randomly, if you are getting any molecule, then how will you find out the hybridization on that molecule? So today we will do this, and let's see, guys, how many of you understand it. And if you have any doubt, hi Priya, hi Srijan. So guys, we are going to start it. So guys, are you ready for it? Just tell me, guys, are you ready for it? Yes. Hello Priya, hello Srijan. Good afternoon everyone. Good afternoon. So I think now I'm audible. Now I'm audible, guys. Okay. So let's start it. Let's start it now. So guys, lecture number 8. Before we start today's class, let me tell you something about myself, guys. I'm Rahul Kaushik. I'm Rahul Kaushik, guys, and I worked in Bansa Classes Kota, and I worked there for continuous 10 years, guys. Okay, and along with not just 10 years, guys, I was head of department, and there I mentored 2000 plus IITs. There I mentored, guys, 2000 plus IITs, and I hope this is my brief introduction and it is sufficient for you guys. And after that, I co-founded my own organization, that is Again Education Private Limited. And now, guys, I'm here on Unacademy to share my experience and knowledge with you guys. Okay, so this is my brief introduction, guys. Now let me tell you about this channel JEE English. So guys, this channel is specifically launched keeping in mind those students who have issues with the Hindi or they can't understand Hindi properly, because in India we have all channels in or for JEE and any other competitive examination. Most of the channels are in Hindi. So to sort out this issue, guys, we are here, and the channel name is JEE English, and we are also there on the Telegram app, guys. Yes, on the Telegram app you can join us, and the link for the Telegram app is given in the description part of this video. Okay, guys. So this is what I was telling you about the channel, guys. Now I will tell you the simple steps how you can subscribe to Unacademy. So step number 1, just go to Play Store or App Store, and guys, download Unacademy's Learning app. Once you have downloaded it, then guys, just install it. Just install it, guys. And once you are installing it, you will be reaching onto this page. And on this page, guys, you have to click on the plus. Okay. So once you are clicking on the plus, guys, you will be getting these options: IIT, JEE, and NEET UG. So once you are getting this, then choose your goal, guys. Suppose you are preparing for IIT JEE, then choose IIT JEE as your goal. Right. So guys, then after that, hit the subscription button, and after hitting the subscription button, guys, yes, then you will be reaching onto this page. And on this page, guys, yes, you have to pay 38,000 for 1 year and 56,000 for 2 years. But if you are applying my code, guys, that is Rahul Cam, remember this code. If you are applying this code, guys, then instead of 38,000 you just have to pay 34,000, and instead of 56,000 you have to pay 50,000. Okay, guys? Yes. Yes, Sweta, actually currently these PDFs are not available. Currently these PDFs are not available. So if even if you are trying to find their link, that is not available there. So even in my lectures, I'm not telling you to download these PDFs, right? But once they are available, I will let you know. Okay, I will surely let you know. So guys, are you ready for the session now? Because after this, guys, some important point is how you guys are going to find out, like what are the benefits, because many students ask me, sir, we are getting everything on the YouTube, so what is the benefit of joining plus? So guys, I'm telling you that on YouTube we are just providing you the lectures, video lectures, but whenever you are preparing for any competitive examination, then just video lectures are not sufficient. Okay, guys? And along with video lectures, guys, let me tell you, uh, the most important part, you need material to solve, you need something to practice. So when you are on the plus, guys, there on the plus, your course would be structured, first point, right? And then we have the second point, along with the structure you will get the modules to solve the problems. And after the modules, guys, after the modules there is one more important thing, and that thing is just a minute, structure course modules, you will have live quizzes there, right? And along with these live quizzes, once your topic is over, then you will also have access to the test series, iconic test series conducted by Unacademy. So these are all the benefits which you are going to get, and you will get the recorded lectures of not just me, but all the lectures of all the teachers who are teaching over there for IIT. Okay, guys. So guys, let's start hybridization. So guys, can you tell me how many of you already know about the hybridization? Please tell me, guys. Yes, once definitely today we will be completing hybridization in previous class. So how many of you have revised the previous class, guys? Tell me. How many of you have revised the previous class where we did types of hybridization, right? SP, SP2, SP3. Nobody revised it? Tell me, guys. Okay. So let's start it, guys. Let's start it now. So now, guys, I'm telling you how to calculate hybridization. So there are some simple rules. So guys, just note it down, this formula. And what is this formula all about? So just note it down, guys. This is the formula, and this formula will give you number of electron pairs. Those can be lone pairs, those can be bond pairs, right? So first of all, just write half, and then write number of valence electrons, guys, and then you can write number of valence electrons. Okay, and then, guys, number of valence electron, after number of valence electron you can write monovalent monovalent surrounding atom. Then if there is positive charge on molecule, then do the minus, and if there is negative charge, then do the plus. I will tell you how to do that. I will tell you, guys. Like, suppose I'm taking NH3, so just calculate the electron pair. Tell me, guys, calculate the electron pairs. Be fast. So let me take some examples over here. Yes, let me take some examples. Suppose I'm taking NH3. So how will you count in the electron pairs? How will you count them? Tell me. So for NH3 guys, I will simply write half. Let me take some dark color. Half. How many valence electron are there? You have 5 valence electron. Then we have 3. It will be 4. Right? So you will be getting electron pairs. Now what will we do with the electron pairs? So first of all, you should try to understand how to calculate electron pairs. So just calculate electron pairs for NH4 plus. Yes, calculate electron pairs for NH4 plus, and then for CO3 2 minus, then for PCl5, and then for CO2. Do it guys. Just do these calculations. Be fast. Be fast. I'm waiting for your answers. Once you are done, let me know and write in the chat box. Write in the chat box, guys. Be fast. So for NH4 plus, it would be guys half into. You can write 5 plus 4 minus 1. Why minus? Because there is 1 plus. So valence electron plus monovalent H. So what are the monovalent species? Normally fluorides, chlorides, bromides, iodide, because they have minus 1 and they usually combine through the single bond. And then we have H. These are the monovalent species. Okay guys. So in this case it will be 4, and here if I am calculating it half, number of valence electron on the carbon guys, right? So number of electron 4. This oxygen is not monovalent, so you will write 0, then you will write plus 2 because minus 2 is there, so you will be getting here 3. And similarly calculate the electron pair. Sunila, it's already going on JEE 2021 on TTS. Yes, it's already going on, Sunila. Tuesday, Thursday, Saturday, I'm taking the fast revision test series. You can check in the playlist. So just guys, now do this one. Be fast. I'm waiting. I'm waiting, guys. Be fast. Be fast, guys. So in this case, it will be half. So valence electron on phosphorus will be 5 plus 5. It is 5. In this case, electron pair, it is half. Valence electron 4 plus 0. Because oxygen is not monovalent, guys. Oxygen is not monovalent. Keep in mind. Got it? Any doubt? Any doubt? So now what will you do with the electron pairs? Now I will tell you guys. Note it down. If you have 2 electron pairs, then I will say S and P. Hybridization will be this. Right? If we have 3, then we will say sp2. If we will have 4 guys, sp3, then I will say sp3d. Got it? And if we have 6 guys, then I will say sp3d2. So these are all the hybridizations. Yes, Rijan. Now you are right. Now you guys are doing good. Got it? So hybridization you can calculate using the electron pairs. Okay guys? And now you might ask, sir, in this formula what is monovalent species? Because I'm saying monovalent surrounding atom. So you might ask guys, what do you mean by, sir, monovalent surrounding atom? So can you tell me? Now I will tell you guys. What do you mean by monovalent? So generally, if these atoms or the halogens are as surrounding atoms, then you can call them monoatomic, and along with them hydrogen. right? If there is oxygen, there is sulfur, then these are not monovalent. Always keep in mind. Got it, guys? And in previous class, when we did hybridization, then I also told you that yes, let's split true and false. Let's split true and false, guys. So just answer me. Yes, all stories in chemistry are man-made because nobody can see them. Many things hybridization can explain, and there are many things which it cannot explain. Then I will teach you the molecular orbital theory. Okay, P and C, the beauty of physics. So now let's move. So these are not monovalent species. So guys, now let's move to the next point, and that point is yes, true and false. Write in the chat box. True and false. So here, guys, tell me hybrid orbitals can make pi bond. Yes. Tell me in the chat box, guys. Be fast. Be fast, guys. True or false? Whatever is your answer, write in the chat box. I think there is some low visibility. Let me switch on some more lights. Yes. Write your answer. It says false. Okay, guys. Let's wait for the others. I think now it's okay. Tell me, guys. Okay, PNC says false. What others are saying, guys? Be fast. What others are saying? Be fast, guys. Are you done with it? So, let me tell you guys here, hybrid orbitals can make pi bond. So this statement is false. This statement is false, guys. Right? Why this is false? Because let me tell you that the hybrid orbital, the shape of hybrid orbital is normally like it. So it is having a big lobe and it is having a small lobe. So what can be done with the big lobe? So when pi bond formation takes place, guys, yes, both lobes should be of equal size. But in this case, if you want to make the pi bond, yes, these two can overlap. But what about other two? So if some orbital is hybrid, then it cannot form the pi bond. If any orbital is hybrid, then it cannot form the pi bond. Got it, guys? Any doubt? So now you got it. So guys, calculate the hybridization now. Okay, Sunila, on Telegram, you can watch the complete playlist. That's there. Yes, you can watch the complete playlist. Okay. Now do this. Guys, calculate the hybridization for this and this. Be fast. Okay, I will give you the notifications. Don't worry. Now do it, guys. Be fast. Be fast, guys. So just count the electron pairs, guys. And I have already told you that once you've counted the electron pair, then if you have two electron pair, hybridization would be sp, sp2, sp3, sp3d, and sp3d2. Got it? So tell me now. Tell me, guys. So now just do it. What is the hybridization of this? So calculate the electron pairs. So in this case it will be half, and for sulfur valence electron will be 6, hydrogen is monovalent. So guys, it will be 4, and it means sp3. Got it? So we are doing guys here hybridization sp3. Yes, p and c, you are right. Yes, p and c, you are absolutely right. So now calculate it for H3PO4, guys. Calculate it for H3PO4. Be fast. Actually, today is there some electricity problem, so I'm teaching over this. But clarity on this is good. हाँ भाई, वंश गहलोत तभी सीखोगे अगर मेहनत करोगे, तो जो मैं बता रहा हूँ ये सबका ही सिखाने वाला हूँ. So again, you will count the electron pair, guys. Write in the chat box. Yes, Anudeep, write in the chat box. So it will be half into number of valence electron will be 5, and there are 3 hydrogens. So 5 plus 3, it will be 4. Okay, guys. So here, just remember this formula: number of valence electron on the central atom plus monovalent surrounding atom plus negative charge and minus positive charge. Right? Got it? So guys, now do this. SF4. And also keep on telling me about the structures. So in this case, guys, we have sulfur. So we have S double bond O, OH, OH. So this is H2SO4. What about H3PO4? You have this OH, and you have again OH, OH. So these are tetrahedral. If somebody asks you the shapes, tetrahedral, this is also tetrahedral. Got it, guys? सिंगल एलिमेंट की कोई हाइब्रिडाइजेशन नहीं होती. No, the beauty of physics B should be something related to physics, and C for chemistry. I'm a teacher and I can answer you like that only. So guys, what will be the hybridization for it? For SF6? Can you tell me? What will be the hybridization for SF6? Half 6 plus 6, and it will be sp3d2. Got it? Tell me now. Okay. So how can you write it, guys? What will be the structure? Now we have this. Right? Now calculate the hybridization for it. Write the electron pair, guys, and write down in the chat box. Be fast. Why -1? Because it is having +1. Okay, okay, Parth. Now focus on it, guys. Yes, it will be 3, it will be sp2, right? So if it is sp2 guys, yes, nh, and you are having, will it have one lone pair? Yes, it will be having lone pair. So what will be its shape guys? You can also predict the shape. So if it is having lone pair, so guys lone pair will be here, and you have h, you have h, right? So it will be bent or v shape. Got it? Yes, Zubair, you guys are right. So let's move to the next. So guys, keep on making their shapes as well. Yes, I want hybridization as well as shape. Now do it for ClO4 minus. Let's do it guys, be fast. I am from India once. Yes, now do it guys. So ClO4 minus, how will you do? Yes, I get your message after 30 seconds. It is not live. There is a lag of 30 seconds, even in the live session. So guys, how will you calculate the electron pair half? Then valence electron will be 7, and oxygen is not monovalent, and we have 1 minus. So guys, it will be 4. So it will be guys sp3. Got it? So shape will be tetrahedral, and structure will be guys, we have 1 O minus. So what I will do? Yes, I will be making 3 double bond more. Yes. If there is single O minus, then there will be only one single O minus, single bonded O. And similarly for this, there is one O minus. Okay, now let me tell you guys. Okay, because there are many students who often face issues with this particular thing. So how you can do it? Now I will tell you guys. Now I will tell you. Suppose I'm writing PO4 3 minus. Right, how will you draw their structures? So in this case, we have 3 minus. So what I will do, I will make one double bond and 3 single bonds and write O minus. It is having only one minus, so I will make only one O minus, and rest oxygen I will connect them through the double bond. You will never do the mistake if you are remembering these things like this way. What about this? Cl, ClO3 minus. Got it? Any doubt guys? Please keep on liking this lecture. If you are really enjoying it, keep on liking it. So now you can make all these structures. Suppose if somebody asks you to draw ClO2 minus, how will you draw it? So you will have one double bond over this. Got it? Any doubt? So if I say SO4 2 minus, so we have 2 minus. So 2 will be zero single bond. 2 will be double bond. This is SO4 2 minus. Got it guys? Now tell me. So let's move now. So again we have ClO3 minus. So just count the electron pairs. So it will be half. It will be half guys. And then you will write 7 plus 1. Oxygen is not monovalent. So again its shape will be sp3 tetrahedral, but instead of 4 we have 3. So we will be having one lone pair. So I can draw the structure tetrahedrally. Yes, it will be like this. So it will be pyramidal. It will be pyramidal. It was tetrahedral, right? In the last class I have told you each and everything about the lone pair. So now tell me guys, for NO3 minus. Tell me. So what will be the hybridization for NO3 minus? So guys, electron pair will be half. Electron pair will be half. Then we have 5 valence electron plus 1. It will be 3. And it will be sp2. Got it? So if it is having sp2 and we have 3 oxygen, 1 minus is there, so how will you connect it? So in this case guys, let me tell you, we have one coordinate bond, then we have one double bond and one O minus. Coordinate bond. Lone pair is donated by nitrogen. Are you getting it now? So now let's move the bend rule for sp3d. This rule is applicable to understand tetragonal bipyramidal geometry, and according to it, always remember it, we have already covered it. More electronegative element prefer to stay at axial position and lone pair and multiple bond prefer to stay at equatorial position. Right, we have already covered this. So now I will tell you guys, yes, what this bend rule is all about. So if I talk about the bend rule guys, this is only for TBP. What is TBP? What is TBP guys? Can you tell me TBP? It is trigonal bipyramidal. This is called TBP. Okay guys. So when I'm talking about the TBP, what does it says? Puppy ready, you did not get voucher. You were in top 100. You got 29. Okay. Just send me your details. I will discuss. Just send me your detail, Puppy ready. Surely I will discuss what is the issue. So if I'm talking about the tetragonal bipyramidal, so if I'm writing PF2Cl3, so how will you draw it? So you have many possibilities like this. Okay, just send me your details and I will surely check it. If you have submitted each and everything, then those vouchers you will get, but not get immediately. It will take some time. So guys, the B option is fluorine, fluorine, and the C option is yes. Now you got it. Now you got it, guys. So we have 3 chlorine over here. We have 2 fluorine. So out of A, B, and C, which one is correct? Tell me, guys. Out of A, B, and C, which one is correct? Be fast. Which one is correct? Don't worry, Papi ready. If you have submitted all details correctly, then you will surely get vouchers. Okay. So, as per this rule, as per the band rule, more electronegative prefer to stay at the axial position. Lone pair and multiple bond will prefer to stay at the equatorial. So, guys, we have here fluorine is more electronegative. So, it will move to axial position. That is right. So, these two options are wrong because fluorine is present at the equatorial. Got it? Similarly, if I ask you, to write this PF3Cl2, how will you draw the structure, guys? No, Zubair, it would not be C, it would be B. It would be B. Right? So now let's do it. Yes. For this, suppose I'm giving you some options. We have P, Option B. Option C. Yes. Tell me now, which one is right? Which one is right, guys? Be fast. I'm waiting for your answers. Be fast. Tell me, guys. A, B, or C? Fast, fast. So in this case, your answer will be, so as per the rule, fluorine is more electronegative. So it should go to axial position. So in this case, chlorine is at axial position. This cannot be your answer. In this case, yes, fluorine is gone. And then we have third fluorine at the equatorial. We have axial chlorine, no. So B will be your answer. Okay, Jobe? B will be your answer. Similarly, guys, if I'm asking you, no, this time it will be B because fluorine is more electronegative. Got it? So fluorine should go to the axial position. Fluorine should go to the axial position. Now, guys, let's do the hybridization through the structure. Do the hybridization through the structure. How will you do? Actually, through the formula, you can get the wrong answer. But if you are doing the calculation of hybridization through the structure, then you will never get wrong answer. Okay, guys? So how will you do that? So let's start now. Let's start. If you know the structure of SO4 2 minus, so we have 2O minus. So connect 2O with the single bond, and rest 2 will be connected by double bond. Now, guys, just count the sigma bonds and the lone pair. So sulfur is having 6 electron and all are bonded, so no lone pair is there. So just count 1 sigma, 2 sigma, 3 sigma, 4 sigma. So we have 4 sigma bonds, right? And if we have 4 sigma bonds, guys, then what will happen? 4 sigma bonds and 0 lone pair. So total electron pair means lone pair as well as bond pair will be 4. So guys, your geometry would be sp3. So this way you can find out, and when you are calculating the hybridization through the structure, then guys you will never commit an error. Then you will never commit an error. Okay. So let's do the hybridization for these. H3PO4, H3PO3 and H3PO2. Let's see, guys, how many of you can find out the hybridization. Okay, if I'm drawing the structure here, you should remember these structures. These are important, guys. Yes. So just count the sigma bonds over here. How many sigma bonds are there? Just count them. So in the first case, guys, sigma, 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 there are 4 sigma, sigma, 4 sigma, and then again you have, so guys, everywhere we have 4 sigma, so hybridization will be sp3. Got it? Hybridization will be sp3. Any doubt, guys? Any doubt, please tell me. So now I'm moving to the next point, guys. Just do the calculation for SO3 now. Just do it for SO3. Do it. Be fast. Yes. So do you know about the structure of SO3 here? I'm giving you sufficient time. Tell me. Be fast. So in this case, you will be writing this. So only 3 oxygen are there and there is no negative charge over it. So I will simply write sigma, sigma and sigma. So 3 sigma means sp2. Got it guys? 3 sigma means sp2. I think now you got it. Any doubt? No doubts now? So sp2 means it will be trigonal planar. Now do it for it. Yes. Now we have 3 oxygens with chlorine. So how will you calculate it? How will you calculate it? So again draw the structures. We have 1 minus. So just draw 1 O and then 3 oxygen with the double bond. Right? In next case again we have 1 minus and the remaining 2 will be through double bond. In next case we have 1 minus and the remaining. So guys, now try to find out the lone pairs. So in this case all 7 electrons are paired up. In this case guys we have 5, so there will be 1 lone pair. In this case we have 3, so there will be 2 lone pairs because chlorine is having 7 valence electrons. Got it? So now count the sigma atom, sigma bonds, sigma, sigma and sigma and sigma. 4 sigma bond are there, and here we have sigma, sigma and sigma. 3 sigma plus 1 lone pair we have, and here we have sigma. So 1 sigma and 2 lone pair we have. Got it guys? Sorry, 2 sigma. So in all case electron pairs are 4, 3 plus 1, 2 plus 2. So guys, hybridization will be sp3 in each case. Right, this way you can calculate the hybridization. And if hybridization is sp3, it means shapes electron geometry will be tetrahedral, but now we have lone pair as well. So in this case we have 0 lone pair, so I will call it tetrahedral. In this case we have 1 lone pair and 3 bond pair, so I will call it pyramidal. We have already done these things. In this case we have 4, so and 2 lone pair and 2 bond pair, so I will call it V shape or band shape. Got it guys? Any doubt? Let me know guys if you have any doubt. So guys, now let's move to the next point. Now calculate the hybridization through structures. So if I talk about ICl3 minus, if I talk about NO3 minus, how you are going to do this? Again, chloride is monovalent species, so iodine is making 3 and then there is 1 negative. So 1 extra electron will be added to the iodine. So valence electron are 7 and 1 extra is there, so it should have 8. So we have suppose just 3. And other than this 3, yes. So 4 electrons will be left. So minus will not be there actually. Minus will not be there. So we will be having 1 lone pair. We will be having another lone pair. So guys, 2 lone pairs and we will have 3 bond pairs. So total we have 5 electron pairs. So its molecular geometry will be TBP, trigonal bipyramidal. And now you have to apply the Bent rule. So as per the Bent rule, more electronegative element will move to the axial position. Lone pair and double bond will move to the equatorial position. Okay, so in this case I is here and we have chlorine here, and now both axial positions are fixed. We have 1 chlorine here and then we have 2 lone pairs. So guys, how this shape will look like? Tell me, this shape will be like a T shape. I think now you got it. So the shape will be like a T shape. Got it, guys? Now just try to calculate it for NO3 minus. Do it. Be fast. Do it, guys. So for NO3 minus, what will be the shape, guys? If I talk about NO3 minus, it would be, so now just count the sigma bonds. So always remember, guys, in NO3 minus, you will have one coordinate bond. You will have one coordinate bond. So 1 sigma, 2 sigma, 3 sigma. So it would be sp2. Got it, guys? It would be sp2. Any doubt? Any doubt, guys? No doubt? No doubt. So guys, now do it for this N3 minus. So if you know the structure of N3 minus, so this will be having plus minus 1 and minus 1. So in this case, if I talk about the central atom, so here guys we have 1 sigma, 1 sigma. So 2 sigma bonds are there. So I will call it sp. I will call it sp hybrid, the central one. As a result, its shape is linear. Okay, guys. Similarly, for I3 minus, yes, what I can do here, we have 2I minus, and then we have 6 because 1 minus is there. So 1 extra electron will be added. So 3 lone pair, 2 bond pair. So 5 electron pairs. So if there are 5 electron pairs, then I will be, we have 3 lone pairs there. So guys, this will be linear. This will be linear. Any doubt, guys, please tell me now. Any doubt? So now you can go vice versa. Either through hybridization, you can tell me the structure, or through structure. So for E, if you are calculating the electron pair, 7 plus 2 plus 1. Plus 1 because 1 minus is there, right? And then iodine is also considered as monovalent. But in this case, guys, it would be difficult to calculate. For N3 minus, how will you do? For nitrogen, you are having 5 plus 1. So as per this, it would be sp2, but this answer would be wrong. Actual answer is sp and it is linear. So formula will not give you correct answer every time. Got it? That's why I am here. I am taking N3 minus. In this case, formula is not going to help you, guys. Not going to help you. Got it? So now what about for multi-electronic centers? For multi-electronic centers. So before this, yes, we can do some more problems over here. Like if I am providing you Cr2O72 minus. So calculate the hybridization of chromium, because here formula is not going to work. So how will you calculate that? So in this case, you should know how to calculate the hybridization, but you can calculate that only if you know about the structure. So just draw the structure. You will be getting like this, and then you have O minus, then you have O minus. Okay, guys. Now you can calculate sigma bonds, because there is no lone pair in chromium. All 6 electrons are participating in the bonding. So you have 1 sigma, 2, 3 and 4. So this will be sp3. Again, this will be sp3. Any doubt, guys? Got it? Tell me. Similarly, if I ask you to find the hybridization of S2O32 minus, how will you do it? So again, you have O minus. Got it? Sorry, yes, S2O32 minus. So in this case, how many sigma bond it is making? Sigma, 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 and sigma. This will be sp3, but it is making one sigma and two lone pair. So it would be sp2 because two lone pair and one sigma bond. But this is making four sigma bond. Got it, guys? And two pi bond it is making, but only we count sigma bonds. So using structure, you can tell me hybridization of anything now. Similarly, if I'm giving you NH3, I'm giving you H2O. So just draw their structures and you can answer it. In case of NH3, you are having 3 NH, 1 lone pair. 3 sigma plus 1 lone pair, sp3. And you are having 1 and 1, 2 sigma and 2 lone pair. So you will be having sp3. Total 4. Because there are 2 lone pair, you will call it bent. Got it, guys? Similarly, can you do it for MnO4 minus? So we have 1 minus over here. So how will you draw the structure? We have O, O, O and this. So just count the sigma bonds now. So 4 sigma bond means sp3. So I think now we have taken enough. So let me take one more, N2H4. Do it, guys. Calculate the hybridization of nitrogen in N2H4. So just draw the structure of N2H4, because without a structure no formula will work here. H, H. Now count the sigma atoms, sigma bonds. Right, and you will be getting sp2. Sorry, one lone pair will also sp3 and sp3. Why? Because in every case you have 3 sigma plus 1 lone pair in all nitrogens. I hope now you got it. So similarly, guys, can you tell me for N2O5? Can you tell me the hybridization of N2O5 now? How will you calculate it? Just do it. So just draw the structure. And if you are getting it, so you are going to get here sp2 and sp2. So it will be planar. Got it? And what about this oxygen over here? It is having 2 lone pairs. So it will be V shape. So this oxygen will be sp3. Any doubt, guys? Any doubt, please ask me if you have. No doubts? Shall I move ahead now? Tell me, guys. Okay. Similarly, if I'm taking CH3, CH3. So what will be the hybridization of carbon? So similarly, just draw it. What will be the hybridization? So 4 sigma bond, this carbon is making sp3, sp3. I hope now you got it. Got it, guys? Any doubt? So now let's start. If I'm asking you CH2, CH2, so how will you do it for CH2, CH2? Any doubt? I will also show you the structures of these ethane and ethene, but how will you do it? Now the way to do it is CCHH. How many sigma bonds are there? So we have here 3 sigma bonds. Got it, guys? Just count the sigma bonds. Similarly, suppose I'm taking here CH, C2H2. So just draw the structure of it. Just draw the structure of it. Be fast, guys. So in this case, what will you do? H and H. Okay. And once you are doing it, guys, what you are going to get then? So 1 sigma, 2 sigma, 1 sigma. So this carbon, this is pi, right? So in this case, this carbon is making 2 sigma, so it will be sp. Any doubt, guys? Please ask me. Any doubt? No doubts? Got it? Now, someone might ask you problems like it. You have CH3, like this. Suppose now I am doing the numbering for these atoms. 1, 2, 3, 4, 5, 6. So can you tell me the hybridization state of each carbon? Without any formula you can do it. Anyone, guys? Without any formula you can do it. So how you are going to do it, guys? So in this case, it would be better if you draw the structure properly, right? Because they will intentionally give you structure like this way. So when you will draw it properly, what will happen? Yes. 1, 2, 3, 6. Got it? So now count the sigma bonds. Easily you can do. For this carbon, if you look carefully, guys, we have 1 sigma, 1 sigma. So only 2 sigma. And this is also making 2 sigma. And this carbon is making 3 sigma. So here we have sp3, sp3, and here we have sp2, sp2. Just count the number of sigma bond that particular carbon is making. Don't count the pi bond, right? So in this case, what it would be? Only 2 sigma bonds are there, so again it will be sp. Again it will be sp. Got it? Now tell me, guys, if you have any doubt. No doubts now? Any doubt? Done? So I think now you are clear about it, how to calculate it, right guys? So can you calculate for carbon suboxide, hybridization for carbon? So I think after today's class, your hybridization concept would be clear. So here you have sigma. This carbon is making 2 sigma. You have this. Got it? Got it, guys? Any doubt? Now, let's do it now. So now you are done with the calculation of hybridization using only structures. Using only structures. Okay, guys? So how do we calculate that? Again, this is done now. So now let me tell you guys how this hybridization will take place. So in this case, guys, we have carbon, that is sp3 hybridized. So there will be, for every carbon there will be 4 orbitals, and those 4 orbitals will be arranged tetrahedrally. One will be below like this, above and below. Are you getting it? So this is for basically one carbon. So in this case, if these are arranged tetrahedrally, now one hydrogen will come here and there will be a carbon bonding through this, and it will look like it. So these three will not be in the, yes, these three will be in the different plane. Got it? So this is C2H6. Here you can see the structure. This green color is for hydrogen and this purple color is for sp3 hybrid orbitals. So this is how 3 hydrogen will be there. One will be below, one will be above. Got it? Any doubt? So this is the case of C2H6. So because in this case 2 carbon atoms are joined by single sigma bond, so they can rotate. They can rotate. Actually, you will learn more about this thing in organic chemistry, especially in stereochemistry. Okay, guys? So if they can rotate, now calculation of hybridization for multi. Now I'm taking C2H4. So in C2H4, what is going on? You are writing the structure like this way. And in this case, I can also say that every carbon is sp2 hybridized. So if it is sp2 hybridized, now what will happen? So it will have 3 hybridized orbitals. I'm making the hybridized orbital like this way. One electron is there, right? And then for another carbon, we are having this. Right? Now what will happen, guys? Now when they will move towards each other. So this is one carbon atom. This is one more carbon atom. So they can make only sigma bonds. Now when they will move towards each other, so one sigma bond will be there. And then we have here one. Any doubt? So we can have one more here. And now we have 4 hydrogens. Got it? So we have 4 hydrogen atoms here. So this is C2H4. But in carbon we have 1s and px, py, pz. So this 1s or 2s is mixing with the 2p, there is a 1p orbital. There is a 1p orbital which is unhybridized, and that will make the pi bond. That will make the pi bond, guys, right? And now let me show you that on hybrid orbital it will be like this. So now pi bond formation will take place. So these all these three hybrid orbital and three of this carbon and three of this carbon will be in the same plane, and this will be above the plane and below the plane. Okay guys, so I can show you. Actually from this diagram it is not clear, but this is sigma, this is pi. So now I will make one more diagram using, my drawing is not that good, let me try it. So this will be like it. So this is the plane we have. Right now we are drawing one carbon atom is here, one carbon atom is here, and then we have one hybrid orbital, and we have right, these six will be in the same plane, six hybrid orbitals, and here we will be having overlap. Now let me show you the hydrogens as well. Got it? And now guys, along with it guys, we have one, yes, it will participate in the pi bond. So this orbital was unhybrid, or I should say it was pure guys. Hi Rithi Music. I should say guys it was unhybrid. So what will happen after the bond formation guys? After the bond formation, so guys, here we are having one carbon, here having hydrogen, 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 and hydrogen. Okay guys, these six will be in the same plane connected by a single bond, right? So this is C2H6. Now there will be a pi bond. That pi bond will be here, and one more, yes, one more cloud will be below the plane. It will be below the plane. It will be below the plane, right? It will be below the plane. Riddhi, today I am using different mic only, but I don't understand why only you can hear the low sound. I think now you should check your phone. Okay. So guys, now you will be easily understanding it. Yes. Here, this carbon, hydrogen, these are in the one plane, and then above this and below this we have this thing. And once they overlap, then you are going to get it. Okay guys, so in single plane you have all these, two carbon and four hydrogen. So six atoms are there in the plane, and above the plane we have electron cloud, below the plane we have electron cloud. Got it? Any doubt? Got it? So now what will happen in case of C2H4? In this case guys, yes, the hybridization is sp, means 1s, and out of 3p only 1p is mixing and 2p are unhybrid, and they will be at 90 degree. They will be at 90 degree to each other, So there will be overlapping of two p orbitals. One will be above and below, and another will be at 90 degrees. So from this diagram you can see, guys, okay, it is C2H4. So this is C2H4 and rotation around, because here we have double bond, so rotation will be restricted and it would be very difficult to rotate them. Why? Because of this pi bond. Got it? Any doubt? Any doubt, guys? So guys, this bond ethylene is severely restricted, because doing so would be, because now if it will move, then pi bond will break, because pi bond is above and below the plane. Pi bond is above and below the plane. If you turn that, then these two lobes would move, and they will, like right now they have like this, and if you move, then there will be no overlap. Right now they can overlap. They can overlap. But if you rotate them, then how will they overlap? There would be no overlapping. So pi bond would not be formed at all. Got it, guys? Pi bond would not be formed. Done? So now if it is done, guys, C2H4 is done. Now let's move to the C2H2. In C2H2, guys, we have one sigma bond and two pi bonds. So two pi bond will be at 90 degree to each other, right? And if this and this, then it would be this and this, right? So if I'm talking about a plane, if we have this plane, so one lobe will be like this. They will overlap, and then there will be one more lobe that will be like this. So guys, and sigma bond will be formed at the center. This is carbon, this is carbon. So there will be only one sigma bond, and hydrogen will be here only. Right, guys? Got it now? Because now if I try to explain you, CCH. So one sigma and two pi bond we have. Right? Now if I'm talking about it, carbon and carbon. So we have this sigma bond, or the hybrid orbitals will be only in this plane. Right? And these are hybrid orbitals. So here we are having hydrogen as well. And now there is overlapping of these two. Right? So this overlapping will be above and below. Now there will be two more orbitals, and those will be like it. Got it? So those will be perpendicular to each other. So this is what they are trying to show. These will be at 90 degree. They are at 90 degree. Their electron cloud is at 90 degree. Got it? Tell me if you still have any doubt. Any doubt, guys? No doubts now? Okay. So guys, this is about the hybridization. Now, what are the limitations of this concept of hybridization? So, hybridization does not apply to H2S and PH3. Why it does not apply? Can you tell me? I will tell you. Because in this case, in PH3, what should be the hybridization? What should be the hybridization? Sigma, sigma, sigma. So it should be sp3, and its structure should be like pyramidal, like ammonia. So this angle should be around, expected angle should be around 107. Got it? But it is nowhere around. This angle, these angles are at approx 90 degree. So 90 degree means there is no hybridization. It means these hydrogens are overlapping with the pure atomic orbitals, and pure atomic orbitals are at 90 degree, because this angle is approximately 90 degree. So no hybridization is applying in them or not taking place. So why hybridization is not taking place? What is the reason behind it? What is the reason behind it? So guys, the reason behind it is will be explained by Drago. So what Drago told us. So today it's almost our time is up. So in the next class, guys, we will be discussing Drago's rule. So what is this Drago's rule and how does it help us in finding those hybridizations, guys? So now let me tell you what we are going to do in the next few classes, guys. Drago rule I will be teaching you. What is Drago rule? After that, guys, the limitation of concept of hybridization, we will keep on doing that. So hybridization does not explain the paramagnetic behavior of oxygen. How, guys? Because if I take the hybridization concept, so in H2O, we have two lone pairs, right? And two bond pairs. So there is no unpaired electron. So it should be diamagnetic. It should be diamagnetic, but actually it is paramagnetic. So what is the reason behind it? What is the reason behind it? Why it is paramagnetic? So hybridization could not explain it. Because as per hybridization, it should be diamagnetic because all electrons are paired up. So there is no logic behind that. Right, guys? And next class, guys, I will be teaching you the back bonding. What is the back bonding and how does this affect bond angle, bond length? That is very important concept. That is very important concept in the next class. So guys, what are the conditions for back bonding? I will be discussing those conditions, guys. So strength of back bonding, what are those factors on which the strength of back bonding depends? And after that, guys, we will be doing not just bond angle and bond length. Actually, how does it affect Lewis acidity or Lewis basicity? So what are Lewis acids and bases? I will be discussing all those points. So the back bonding and how back bonding affect the hybridization as well. So hybridization of this and hybridization this nitrogen is different in both the cases. So I will be discussing, guys, why these hybridizations are different. What is the logic behind it, right? And then electron deficient bonding, we will talk about electron deficient bonding. During that bonding, I will tell you the basics of Lewis acids and Lewis bases. Okay. And after that, guys, I will discuss these hydrogen bonds and all those points. So these are the things. What are the conditions for hydrogen bond? And not just the conditions, guys. How does it affect the density? Hydrogen bond. Density of ice is lower than the density of water. Why? So all these questions to be answered in the next class, guys. Yes. So how does this hydrogen bonding affect each and every point we will be discussing, guys? How many types of hydrogen bonding is there? Intermolecular, intramolecular, and what is the effect on solubility, melting point, boiling point, viscosity of hydrogen bonding? All these points, guys, all these points will be discussed in the next class. So stay tuned, guys, stay tuned. And I hope today you enjoyed the session, guys. And I will meet you again in the next class, guys. If you really like this session, guys, please share it and like it and click on the bell icon so that you can get our latest notifications. And once you have checked in, guys, just below the description part of this video, guys, just click on this is our Telegram channel. You can subscribe to it and the link is given below the description part. Now, guys, how you can subscribe to Unacademy? There are some simple steps. Just go to Play Store or App Store, download Unacademy's learning app and install it. Once you have installed it, guys, then click on the plus. So once you are clicking on the plus, then you have to choose your course. right? If you're preparing for IIT, then choose IIT JEE as your goal, and after this, hit the subscription button. Once you are hitting the subscription button, guys, then you will be getting my code Rahul. Can apply this code to get the discount, because if you are applying this code, guys, then for 1 year, instead of 38,000, you just have to pay 34,000. For 2 year, instead of 56,000, you have to pay 50,000. But guys, if you are applying my code, if you are not applying it, then you are not going to get it. So remember this code, guys. Remember this code, it's very important. Got it? So this is the fee structure. And guys, what are the benefits which you are going to get? So once you are on the plus, you will have live quizzes, you will have structured course, you will also have access to the video lecture and content by all the educators who are teaching there for IIT. Okay guys, so not just these things, you will be having access to the iconic test series. So guys, there are so many benefits which you can get just by paying 34,000 for 1 year or 50,000 for 2 years. This fees is nothing. So I hope guys you got it today, and this is all for today guys, and take